Okay, our first actual problem. Now we'll be able to review how to find the eigenvalues and eigenvectors. With this one, we're not going to prove why this method works. That's back in Unit 4, so if you want to go back and look at that, please do, but I'm not going through that again. And so what we're going to do is first we're going to write out what our matrix M is. It's the coefficients of the variables. We have 1 and 1 here. So our matrix will be 1, 2, 2, 1. Which is the one we saw on the previous page. So we actually already know one of the eigenvalues, but let's see how we got that. You subtract lambda from the top left and the bottom right elements in the matrix. And then you set the derivative of this, not the derivative, sorry, the determinant of this matrix equal to 0. To find the determinant, you multiply these minus multiply these. So we're going to set the determinant equal to 0. The determinant then is 1 minus lambda times 1 minus lambda minus 2 times 2. Set that equal to 0, and we have a quadratic. 1 minus 2 lambda plus lambda squared minus 4 equals 0. So we have lambda squared minus 2 lambda minus 3 equals 0. And we can factor this quadratic to find our two eigenvalues. So we have lambda minus 3 and lambda plus 1 equals 0. And you get lambda 1 is 3 and lambda 2 is negative 1. You can always solve a quadratic using polynomial root finder in your calculator if you'd like as well. Okay, for lambda 1, we're going to find the eigenvector that corresponds with 3. To find the eigenvector, you have the matrix 1, 2, 2, 1 times some eigenvector. This goes back to what we saw on the previous page, is equal to the eigenvalue times that same eigenvector. So what is the vector that makes this a true statement? Or there's an infinite number of vectors. We just have to find one, an eigenvector. 1, 2. So we're going to multiply row times column. So I have 1 times x plus 2 times y equals the top row here, 3x. I just choose the top row first because it's easiest to work with. Just choose the top. You could also do the same idea with the bottom row if you'd want to, the 2, 1 on the bottom. So that's x plus 2y equals 3x. If I subtract x from both sides, I get 2y equals 2x and x equals y. So an eigenvector is any eigenvector where x is equal to y. The easiest one would be 1, 1 there. We'll do the same with lambda 2, which is negative 1. So we have 1, 2, 2, 1 times xy equals negative 1 times xy. So that's x plus 2y, or top row again, x plus 2y equals negative x. 2y equals negative 2x. So y equals negative x, or x equals negative y. Either way, doesn't matter. If you remember, what you want to do is you want to choose a number to substitute in for x, a convenient number. Well, I'm going to let x equal 1. If x is 1, be careful here. A lot of students make mistakes, especially when you have like a coefficient like a 2 or something in front of here. So what you always do is take a convenient number to substitute in for x. If x is 1, then what is y? Y would be 1 times negative 1. So we'll use 1, negative 1. That is one possible eigenvector. There are an infinite number, but ones are easy to work with. And now we can write the general solution. The general solution is x equals, what was it? A E. So this is the formula on the front page. A e to the lambda t, and we'll do the first lambda first, 3t, times the eigenvector that corresponds with it, which is 1, 1, plus b e to the negative t. So the other lambda is negative 1, lambda 2, times the eigenvector 1, negative 1. This is the solution, or your final answer is right here. This does mean, just to make sure we understand, this is xy equals a e to the 3t times 1, 1, which is just a e to the 3t, a e to the 3t, plus b e to the negative t, negative t times 1, negative 1. If you wanted to, you could find just x. If you wanted just x, and we'll see this in the next problem where this becomes important, I found x is equal to, I would just multiply through the top here. So I would have a e to the 3t plus, and then I would multiply b e to the negative t times negative, or times positive 1, because that's the top component. So I would have times b e to the negative t. And I also have an equation for y now. A e to the 3t minus be to the negative t. So you can separate them. You shouldn't. You don't need to. But you do need to understand that that's what this does mean. It is an x and a y. In the next problem, we'll look at how to find those coefficients a and b.